The following content is provided under a Creative Commons license. Your support will help MIT OpenCourseware continue to offer high-quality educational resources for free. To make a donation or view additional materials from hundreds of MIT courses, visit MIT OpenCourseware at ocw.mit.edu.
So today is the Human Power Lab, and we're going to start with a lab safety tour that Gwyn is going to run. This is Gwyn Jones, who's a D-Lab instructor. He's teaching D-Lab design with a couple other people this semester and has a lot of shop experience and a good person to have as a resource around. So he'll do the safety tour. Once you have the safety tour, then you guys are free to use the lab after hours, which is a nice resource. And then after that, we're going to split up into teams, try to divide the class evenly, and I think we're at about 16 students, so 5 or 6 students per team. And each group is going to do a different thing, and then we're going to switch twice so that everyone does everything. So the 3 options are machining with Gwyn in the D-Lab lab, which I think is 102, but that might be a lie. Water carrying, which will start up here with me. And water pumping, which will be outside in the driveway, outside the D-Lab. So make sure you know where your coats are if you're not wearing a sweater, because it's a little chilly out. And then we'll rotate, and hopefully we'll get done a little early today, but not a ton early. So we'll see. There's 5 of you, so one person is going to be the spotter because some of these water carrying methods are rather challenging because the tour that you're going to do 4 times 5, one is a spotter, to do all the attempts, you're going to go down this hall, down the stairs, outside, cross the street, and then come back. And so that's to experience flat surface, nice and easy, stairs, more or less easy depending on the method, and then some rough terrain. So that's the plan. And the methods are traditional American style. A method that's common primarily for women all over the world, and I may need help to get this up. Yeah, I'm totally going to need help to get this up. So you just work to get it centered, and then hypothetically you can do this with no hands. I've yet to meet any D-Labber who can do that, but you meet plenty of people who can in developing countries. But try to get to one hand when you're doing it. And if you see people who have been doing this their whole lives, not only, ooh, that was really bad. Good thing we have 2. Not only can they do it with no hands, but they your head has a point in the middle, so they'll start on one side, and then when they get tired, they'll just go like that and switch to the other side, and it works, which I don't know how you do that. So that's 2 methods. Number 3 is called a tump line, which is used in many developing countries as well, often in the same places they do head carries. And so for this one, it goes on your forehead, and it uses your neck. And you kind of play with it to get it comfortable on your neck. In areas where this is really common and people are carrying 1 to 2 times their body weight, you see most of their foreheads have ridges because it just digs in because you're carrying from a pretty young age. And then the last method is called the Q drum, which you can see here, which was invented, actually, there's 2 different groups that do it. One is the Q drum, one is the hippo roller. And the idea is to help kids carry water very far distances. So a lot of people are carrying water many miles or at least a mile every single day. They're usually kids and women doing it, and so we're not even going to come close to a mile, and we're generally carrying less water than they are. And we ate a much better breakfast and got a much better rest and are in much better health. So it will be a little annoying, but not as annoying as it would be if this is your life. So just a little snapshot. So come on around, let's get started. That actually looks pretty good. let it go down step by step. Come on, no hand. Crown on me. Hi, everyone. Oh, this is much easier when I can see it.
What we kind of want the point of this module to be is for you to understand how much power we can generate with your arms versus legs. And so this is a pump that uses your legs, and that's a pump that uses your arms. Everyone here is going to use both pumps and try to fill the bucket and see how much power you can generate. This pump was a redesign on a plastic injection molded pump that was done by the Full Belly Project by Jock Brandis, and he made the entire thing out of cement. It's way more applicable for the developing world. So you can measure power by pressure times volumetric flow. So we're measuring volumetric flow by how quickly we can fill a 5-gallon bucket with water. And the way we're measuring pressure is we're going to use the hydrostatic pressure equation, which is rho GH. And so we're going to measure the height that we're pumping the water to, and then just multiply it by the density of water and gravity. Okay, you ready?
Go for it.
Okay, go.
Okay. He's like stuck. Yeah.
Maybe just take it out of the water.
Yeah, this is tiring. Yeah, it's a workout.
Nice. Okay. These are blocks.
That's good.
Okay.
245. What happens is when water pushes down on gets pushed down this way, it pushes the marble against that inner lip and creates a seal. And then on the top you have a PVC pipe that has either a nail through it or is bent to close it in some way, so that when water gets pushed this way, it pushes against this lip and then water can flow around the marble, and so it creates a one-way valve. And it's actually a really good one-way valve, and the cool thing about it is it gets better with time because the plastic bends around to the shape of the marble instead of other one-way valves which get much worse with time.